students, welcome to the new session for the chapter Haloalkanes and Haloarenes. From the past few sessions, we have been doing the preparation of haloalkanes. In the last class, we have discussed the Grove's process, which is the preparation of haloalkanes from alcohols by using Lucas reagent. Today, we will be continuing the same preparation from the same compound alcohol. Okay, we are going to prepare haloalkanes, but here we will be using other reagent. In the previous session, we have used Lucas reagent and prepared haloalkane from alcohol. Today, the next reagent we are going to use is PCl5 phosphorus pentachloride. Okay, forming your haloalkane. Okay, what are the byproducts here? You get PCl3 plus HCl. Now, when we talk about the reagent, like in the previous session also we were talking about Lucas reagent, what is the importance of Lucas reagent, what was the role of ZnCl2 and all that. So today we will try to throw some light on PCl5, the reagent which is there here. PCl5, as you know, is phosphorus pentachloride, but very important thing here, PCl5 exists both in the form, gaseous form and solid form. Now, when I say PCl5 exists in gaseous form, PCl5 in its gaseous form exists as individual PCl5. So, in the exam, if they didn't give if it is solid or gas, you take PCl5 being in gaseous state and go with the mechanism. But if in the exam they specifically said PCl5 is in solid form, then your PCl5 exists in the form of a dimer. Okay, then your PCl5 exists in the form of a dimer. Now, either you take PCl5 as gas or PCl5 as solid, the products remain the same. But the change comes with the mechanism. Now, when I say the change is the mechanism, then definitely there will be a change in the stereochemistry of the products formed. So, you should be able to understand, the difference when PCl5 is used as a gas and when PCl5 is used as a solid, so that you will not do any mistake in predicting the stereochemistry of the product formed in the reaction. Now, let us discuss the mechanism involved so that we can understand the stereochemistry, and in exam it will be very easy for you to predict the stereochemistry of the product. If it is PCl5 as gas, what is the mechanism, and if it is PCl5 as solid, what is the mechanism? Okay, hope the line is straight. No, let me make it little straight and neat. Okay, fine. Okay, on the left side, I will be doing mechanism of PCl5, okay, as gas. Okay, and on the right side, we will be doing the mechanism of PCl5 as solid. Now, as I told you, PCl5 as solid will exist in the form of a dimer. Now, when PCl5 exists as a dimer, when it breaks, okay, when you break PCl5 as dimer into ions, it will be giving your PCl4 plus cation plus PCl6 minus anion. So both, okay, PCl5 as such will not be involved in the mechanism in the dimer form, but PCl5 breaks as PCl4 plus cation and PCl6 minus anion and interferes in the reaction, involves in the reaction. How it involves and what it does, we will see in detail. First, let us go with the mechanism where PCl5 as a gas is interfered. PCl5 exists in its normal structure when it is in gaseous form. So first, we will finish this mechanism. ROH, alcohol, you know oxygen is there with its lone pair, two lone pairs of electrons on oxygen here, plus PCl5. Now if you, okay, the normal PCl5. Now when we talk about PCl5, you know phosphorus is surrounded by 5 chlorine atoms and chlorine is very highly electronegative atom. So chlorine will try to pull the shared pair of electrons more towards it. Phosphorus, okay, it's very happy. Phosphorus has been surrounded by 5 chlorine atoms, but all the 5 chlorine atoms being highly electronegative are very selfish and they always try to keep the shared pair of electrons towards them only. So when phosphorus sees an oxygen, and we also know phosphorus has vacant d orbital with it. Okay, you have studied this in chemical bonding. Phosphorus has vacant d orbital with it. Now, when phosphorus sees lone pair of electron on oxygen, it will be like, okay, I have 5 chlorines, but everyone is so selfish, pulling the electrons towards itself. So, it will try to take electrons from the oxygen atom. Okay, it will try to take electrons from the oxygen atom. Now, when phosphorus takes the electrons from the oxygen atom, then chlorine will be like, okay, let me run away with the shared pair of electrons now, because now phosphorus is like very happy in its zone by taking electrons from oxygen. So this chlorine will leave as Cl minus. This chlorine will leave as Cl minus. Okay, this chlorine will be leaving as Cl minus. Chlorine will definitely go with its shared pair of electrons only, because you people know both phosphorus and chlorine are non-metals, and out of them chlorine is more electronegative, pulling the shared pair of electrons towards itself. Now if you see what is formed here, R, oxygen has lost its lone pair of electrons, so it will get positive charge, and hydrogen here, so phosphorus is there here, and phosphorus is now there with its 4 chlorine atoms. 4 chlorine atoms. Now what happens is, if you see the product, you can definitely see the formation of HCl. Now in chemistry what happens is, once the reaction is done in the laboratory, once the reaction is proven, once you know the products, then the scientists and the chemists will try to predict the mechanism. Okay, if this is the respective product, might be this mechanism would have been involved. If I am getting HCl, might be this mechanism would have been involved. If I am getting PCl3, might be this bond would have been broken. This is how we come to a conclusion about the mechanism. It is not like at first I write the mechanism and then do the reaction. No, I can write my own reaction. It is not that that reaction is possible practically. So once a reaction is proven, okay, that it can happen in the lab, and once you get stable products, then we will think about the mechanism that, okay, if this happens, this is the possibility. If this happens, this is the possibility. So this might be the mechanism. That is the reason I got these products. This is how chemistry works. Now if you see here, we see the formation of HCl. So definitely hydrogen has come out from this molecule. So what did oxygen do? Oxygen had two opportunities, either to pull electrons from here, or pull electrons from here, or to pull electrons from here. Because you have POCl3, this bond has not been broken. Yes, now because okay, now what will happen? Now we have HCl, so hydrogen would have left the molecule as H plus. So oxygen would have taken this shared pair of electrons towards itself, because you know oxygen is not stable with its positive charge because of its high electronegativity. Now what happens here? You can see here hydrogen has, okay, now hydrogen will be has H plus. Okay, hydrogen will be as H plus. The hydrogen because it comes out as H plus, it will react this with this Cl minus, forming HCl. Okay, forming what? HCl. Forming what? HCl. So what has come out of the molecule? HCl has come out of the molecule. From here Cl minus has come out. From here H plus has come out, resulting in the release of HCl. That HCl you can see here. Now what did I get? R. Okay, this has taken back again its pair of electrons. Here it still had this other lone pair. If you want, you can show it. If not, it's fine. Okay, this lone pair is still there, so that lone pair will still be there. Oxygen has taken the shared pair of electrons from oxygen, so it is back with its two lone pair of electrons. Now here phosphorus is there with 4. Okay, with 4 chlorine atoms. Now what will happen? Now what will happen here? Now phosphorus is like, okay, now oxygen again has 2 lone pair of electrons, and it is always like more interested in to take from oxygen, because 4 chlorine atoms are like pulling electrons towards them from phosphorus. So now what will happen? This lone pair of electrons phosphorus will try to take. So one more chlorine will leave as Cl minus from the molecule. Okay, so now what do I get here? Okay, R. Oxygen, because it has donated its lone pair of electrons, it will get a positive charge. This will become double bond phosphorus Cl. This Cl minus is gone. Okay, the Cl minus is gone, and it is there. Previously the Cl minus, which has been lost from phosphorus, reacted with H plus, forming HCl. But here this Cl minus cannot find any H plus to form HCl, so it is still there. And it is a reactive species. It is like seeing way to go. Okay, seeing way to go. Now what this Cl minus does is, this Cl minus will try to attack this R. Okay, will try to attack this R. Why is R alkyl group very much interested to bond with chlorine? Because this oxygen has positive charge, right? This oxygen has positive charge, so it has become very unstable. So this oxygen starts pulling electrons from this RO bond. This oxygen starts pulling electrons from RO bond. So R group becomes very electron deficient. So chlorine will happily go and attack R, forming what? Okay, forming what? RCl. Forming what? RCl. Okay, forming what? RCl. Because this oxygen has got it bond pair of electrons, it will form, okay, POCl3. It will form what? POCl3, which is there in the product. Now the main thing you need to focus here, here the nucleophilic attack has taken place. Now did the nucleophile, did the nucleophile come from some other reagent? No, the nucleophile came from within the molecule. Here, if you see in this molecule, then okay, Cl minus left the molecule. Chlorine has left the molecule as Cl minus, and it is again attacking in the same molecule. So within the molecule, all the thing is taking place. Nothing is coming from outside. Cl has left as Cl minus from this molecule, and again in turn, in that molecule only it is going and attacking some other atom. So what kind of substitution reaction is this? Is it SN1? It is not SN1, because if it is SN1, the mechanism would have been taking place through carbocation. So it is definitely not SN1. Is it SN2? It is not SN2. If it is SN2, the nucleophile would have come from some other external source or from some other external reagent. And if it is SN2 mechanism, you will get an inversion product. Keeping all that in mind, if you see here, okay, everything is happening within a molecule, so it is intramolecular. So it is definitely intramolecular nucleophilic substitution reaction. Okay, intramolecular because it is happening within a molecule, nucleophilic substitution because one nucleophile OH is gone, because OH is a nucleophile because it is electron rich species. One nucleophile is gone and it is being substituted with other nucleophile. So it is nucleophilic substitution reaction definitely. But which type of nucleophilic substitution reaction? SNI reaction. It is intramolecular nucleophilic substitution reaction. Okay, intramolecular nucleophilic substitution reaction. So reaction of alcohol with PCl5 in gaseous state to give haloalkane plus POCl3 plus HCl follows which mechanism? It follows SNI mechanism, and this mechanism is in front of you. Now, whenever a product is formed by intramolecular nucleophilic substitution reaction mechanism, okay, it will be your retention product. So, the configuration in terms of stereochemistry, if I talk, the configuration is retained. Okay, yeah, okay, the site, okay, wherever alcohol has been there, from that place only Cl has been substituted. So the configuration will not get changed. The configuration gets retained. So I will get a retention product. I was talking in very much detail about stereochemistry, retention and inversion when I was doing Lucas reagent Gross process. Here I am saying retention product. Now you should you will obviously have many doubts because you will be saying, ma'am, here it is not a chiral carbon. I'll take an example. Here I have generally I wanted to show the mechanism. So I have taken just an alcohol. I will take a alcohol which has chiral carbon because to show a retention or to show inversion, this has to be a chiral alcohol. So I will take an example of chiral alcohol and clearly show you retention and inversion there after I complete the mechanism for PCl5 in solid state. Now here if you see, let us do the mechanism here. Okay, alcohol is there and alcohol reacts. First PCl4, okay, the plus cation will come. So here if you see phosphorus, and I have my 4 chloride atoms with phosphorus holding positive charge here. Okay, with phosphorus holding positive charge here. Now as I told you, phosphorus first of all, here only it was failing to take electrons from oxygen because all the chlorine atoms were pulling electrons from it. So here it is there in positive charge. So it would definitely want to take electrons from oxygen. It would definitely want to take electrons from oxygen. So what will happen here? Oxygen, oxygen attacks by giving its lone pair of electrons. So what do I get here? Oxygen will have its positive charge. Here I have my hydrogen. Okay, now what do I get here? Here I have my phosphorus. Phosphorus will now not have its positive charge. But chlorine will not leave. Chlorine will not leave because phosphorus was in deficit. Now that deficit has been solved by taking lone pair of electrons, but chlorine will not leave because phosphorus wants to have 5 bonds, so chlorine will not leave, but just this positive charge which was there on phosphorus will get neutralized because it is taking a lone pair of electrons from oxygen. Here it already had 5 bonds, still it was taking a lone pair from oxygen. That is the reason one chlorine have to leave because its valency can be 5. That is the reason here Cl will not go, but just the positive charge will get neutralized. Cl. Now I want you to think in the same way as you thought in the previous case. Here now what will happen? Here what will happen? Okay, now oxygen has the option of taking the shared pair of electrons towards itself because it is not stable with positive charge. So it will not take electrons from this bond because we know POCl3 has been formed. So this bond should remain intact. That is the reason it will take its shared pair of electrons from this hydrogen. So hydrogen will be leaving the molecule as H+. Okay, hydrogen will be leaving the molecule as H plus. Now if you see here, this lone pair of electrons, okay, this shared pair of electrons has been taken by oxygen, so oxygen will positive charge is gone. Now it will get back its lone pair of electrons. This lone pair of electrons is there here. Okay, so R O. Okay, previously it had this lone pair, now also it has, but now it has taken this shared pair of electrons, so again it is back with its two lone pair of electrons. And again I have my phosphorus Cl, okay, and Cl. Okay, Cl and Cl. Now what happens? Let us try to understand. Now now phosphorus will be like, okay, now phosphorus will be like, let me take the lone pair of electrons again. It is always so interested to take electrons from oxygen, so it will try to pull this lone pair of electrons from oxygen. Now what will happen? You will get R O plus, it has the other lone pair of electrons, double bond phosphorus Cl. Now when phosphorus has taken lone pair of electrons from oxygen, now chlorine is like, okay, now chlorine is like, see, you have 5 bonds. Okay, you would have stayed happily, but still you are interested to take it from oxygen. Okay, but still you are interested to take it from oxygen. So now you are getting your double bond. So let me leave. Okay, let me leave because you don't need me now. Okay, you are taking, you have already formed a bond with oxygen, but still you are not satisfied. You are taking one more lone pair from oxygen, forming a double bond, so you just don't need me now. So chlorine will leave as Cl minus. Now here H plus, from here H plus, okay, from here Cl minus, okay, from here H plus, from here Cl minus. Together they will form what? HCl. Together they will form what? HCl. And okay, HCl molecule will leave. Okay, HCl molecule will leave. H plus from here, Cl minus from here. Together they will form HCl, and HCl will leave. Okay, here what is there? Okay, now phosphorus has 3 chlorine atoms here. Now phosphorus has 3 chlorine atoms here. Now what will happen? Oxygen definitely wouldn't want to be in positive charge. So oxygen will try to pull the lone pair of electrons from, okay, R group. Okay, oxygen will try to pull the lone pair of electrons from R group. Now what happens? Okay, now let us try to understand something here. Okay, we have PCl6 minus, This PCl6 minus will break down into PCl5 plus Cl minus. So here, what is the role of PCl6 minus here? PCl6 minus will give out Cl minus, which will act as the nucleophile. Okay, which will act as the nucleophile. So Cl nucleophile is coming from an external source here, from PCl6 minus it is coming. If you see here in the mechanism, it was coming, okay, it was not coming from a different source, it was happening within a molecule. So this was SNI. Because it is coming from the other source, now it is no longer SNI. Now this Cl minus will attack on R. Okay, this Cl minus will attack on R from backside. Okay, from backside. And because the nucleophile is attacking attacking from the backside, and there is no carbocation formation, so this is your which mechanism? SN2 mechanism, your nucleophilic substitution reaction, and it follows SN2 mechanism. Because this Cl minus attacks here, it will form RCl, and you people know SN2 mechanism will form which product? Inverted product. Okay, it forms which product? It forms here inverted product plus. Okay, now you people can see here oxygen has taken its electrons, so oxygen got back its 2 lone pair of electrons, and what came out from the molecule? POCl3 came out from the molecule. Now HCl has come out here, POCl3 has been formed here, RCl has been formed here. But when it comes to PCl5 solid, your product will have an inverted mechanism. When it comes to PCl5 gas, your product will be a retention product. Clear with this? Okay, if you see the mechanism here, PCl4 will come here, PCl4 plus, so oxygen's lone pair of electrons will attack on phosphorus because it is in deficit of electrons. Now what will happen? Oxygen will take the shared pair of electrons from hydrogen, and hydrogen will leave as H plus. Phosphorus is still greedy to take the electrons, so it will take the lone pair of electrons from oxygen, forming double bond with oxygen. So chlorine will be like, you now have your 5 bonds, let me leave. H plus from here, Cl minus from here will leave as HCl. Oxygen is not stable with its positive charge, so pulls electrons from R. In the meanwhile, your PCl6 minus comes into play. It will release Cl minus. That Cl minus acts as a nucleophile and attacks from behind on R, forming RCl. As it follows SN2 mechanism, RCl will have an inversion configuration, and along with that POCl3 has been released. So this is the difference in mechanism. When it comes to PCl5 as gas, it is retention. When it comes to PCl5 as solid, it is your inversion product. Now let us take an alcohol which has a chiral carbon. Okay, now let us take an alcohol which has chiral carbon to understand the retention and inversion in a better way. Hope this mechanism is very clear for you. In exam, okay, we either way the product is same. There is no doubt in it. If it is gas or solid, the product will be same. But the thing is, if a very good question comes, you should be able to know if you are getting a retention product or inverted product. For that, I have taught you the mechanism, why it is retention here and why it is inversion here. It is SNI here and SN2 here. The reasons also I have explained. Now let us see through an example about the stereochemistry of the product formed by SNI and SN2. Now let us take a chiral alcohol to understand the mechanism better. So I have taken a chiral alcohol where my carbon is surrounded by 4 different groups. One side with ethyl, one side with methyl, one side with hydrogen, and the other side with OH group. Now when we go with PCl5 being in gaseous form, I just explained you it will be like SNI mechanism. If it is the SNI mechanism, I should get the retention product. So Cl minus substitutes OH. Okay, and Cl minus will attack and stay on the side where OH was there. So what will I get? I get the retention product here. So Cl will come and attack and take the position of OH which was previously there. Now the remaining groups will remain same. CH3, it is my C2H5 here and hydrogen here. Okay, so chlorine is there in the same position as OH was there before. So I can say my configuration has been retained. So this is my retention. Plus POCl3 plus HCl is as usual. Okay. So for example, if this has D configuration, this also will have D configuration. For example, if this alcohol has L configuration, this haloalkane will also have L configuration. Okay, so in retention, whatever configuration the initial compound holds, the product also will hold the same configuration. If this is D, this will be D. If this is L, this will be L. Okay, so that is your retention. Now when we take PCl5 solid, I told SN2 mechanism will happen here. So you will get an inverted product. So Cl minus will be there on the opposite side of OH group. Okay, if OH group is on the onto the right hand side, now your Cl minus will be onto the left hand side. Okay, so here my C2H5 will come this side because you get an inverted product. Cl minus will attack from the side opposite to that of your OH, so it will come onto the left hand side. Okay, so here it is my CH3 and H. This is my chiral compound and this is the inverted product. Okay, so what will happen here? Inversion will happen here. Remaining POCl3 plus HCl will remain the same. So if this is D, this will be L. If this is L, this will be D. So you can see a clear inversion of configuration because this happens through SN2 mechanism. Now we can talk about retention and inversion because I have a chiral carbon here. For example, if I take a reaction, okay, if I take a reaction in which I don't have any chiral carbon, for example, C2H5OH plus PCl5 gives C2H5Cl plus POCl3 plus HCl. Okay, if I take this reaction, in this also alcohol is reacting with PCl5. Okay, and giving C2H5Cl plus POCl3 plus HCl. So irrespective of whether it is PCl5 gas or whether it is your PCl5 solid, it doesn't make a difference to the configuration here. Either you take your PCl5 gas or your PCl5 solid, we know the products are always same. Even if it is a chiral carbon also, products are same. But if it was a chiral carbon, I could see a clear difference in the configuration part because it had a chiral carbon. But here when I take C2H5OH, it doesn't have any chiral carbon. So irrespective of whether my PCl5 is solid or whether if my PCl5 is gas, it will give C2H5Cl, and here your configuration doesn't matter here because we will not talk about any configuration or optical activity because there is no chirality. So we only talk about retention and inversion if the initial whatever alcohol we have taken is having a chiral carbon. As long as there is no chirality involved, we cannot talk about retention and inversion. So here we will not talk about any stereochemistry being involved. Now here, okay ma'am, so if in the exam, I'll take one more case here. If in the exam you have got a question like this, okay, C2H5OH plus PBr5, okay, plus PBr5. Then if you are writing the answer as C2H5Br plus POBr3 plus HCl, then this reaction is totally wrong. This reaction is totally wrong because, okay, this reaction does not happen only. This reaction does not happen because PBr5, PI5, okay, PBr5, PI5 do not exist. Okay, because PBr5 and PI5 do not exist, there is no point of them reacting with C2H5OH and giving C2H5Br. So only PCl5 existence. PCl5 is a stable compound. So we are talking about the reaction. We are talking about the formation of some retention or inversion because this compound as such exists in a stable form. But when we are talking about PBr5 and PI5, they are not even in a stable form. They do not exist only in normal state. They are not stable forms, so they don't react only with PBr5 and PI5 because they are not stable forms of phosphorus halides. Okay, so in exam, don't put blindly C2H5Br and come because that reaction will not happen because PBr5 and PI5 are unstable. So this is about retention, inversion and stereochemistry involved when it is PCl5 gas and PCl5 solid. And we talk about stereochemistry, inversion, retention only when it is chiral carbon. We will not talk about any stereochemistry if the alcohol is having an achiral carbon. So this is about your PCl5 stereochemistry with an example and about PBr5 and PI5 not being stable and the impossibility of the reaction. Mostly these reactions don't take place. Now we are done with PCl5. Hope you understood the full mechanism and everything involved with respect to PCl5. Now let us do the reaction of alcohols with PCl3 forming RCl and whatever it is. So now till now we have done with PCl5 phosphorus pentachloride. Now let us see the reaction of alcohols with phosphorus trichloride, which is my PCl3. Let's see that. Now let us see the preparation of haloalkanes from alcohol using PCl3. So previously we have seen preparation of haloalkanes from alcohols using Lucas reagent. Then we have seen preparation of haloalkanes from alcohol using PCl5 in both gaseous form and solid form and how the stereochemistry is different over there. Now we are going to see the preparation of haloalkanes from alcohol using PCl3, which is my phosphorus trichloride. Now when we make alcohol react, now if you see a very important observation, 3 moles of alcohol react with PCl3 forming 3 moles of RCl plus H3PO3. Now when we talk about this reaction, why do we need 3 moles? Okay, and how do 3 moles react with 1 PCl3 and give 3 moles of RCl and H3PO3? Let us see it and understand it in a better way by knowing its mechanism. Now when we see the mechanism of this reaction, first let me take 1 mole of alcohol. Oxygen has its lone pair of electrons. Now it will react with, okay, PCl3. Now as I have been telling you, even in PCl5, phosphorus would want to take the lone pair of electrons from oxygen. Okay, would want to take the lone pair of electrons from oxygen. Now what will happen when phosphorus takes the lone pair of electrons from oxygen? This Cl will go along with its, okay, this Cl will go along with its lone pair of with its shared pair of electrons and become Cl minus. Now because oxygen has lost its lone pair of electrons, oxygen will get a positive charge and it will have the hydrogen here. Now here phosphorus will be there along with, okay, phosphorus will be there along with two chlorine atoms. Now if you see this reaction further, I told you when I was teaching you PCl5 also, mechanism is assumed based on the product's form. Now if you see the product, we have RCl plus H3PO3. So definitely this bond has remained intact and hydrogen didn't come out as HCl. Okay, hydrogen didn't, in the previous case when I was doing PCl5, hydrogen has come out as H plus and it has formed HCl. So I was very clear there that this shared pair of electrons has been taken towards oxygen. Now that is not happening because I see my formation of H3PO3 but not HCl. So I cannot talk about this hydrogen coming out. So what would have happened? What would have happened? RCl has formed, but nothing of this, nothing from this side has been, okay, has been disturbed much. So might be it was assumed that this Cl minus, okay, this Cl minus which has been lost, which has been lost from phosphorus in this case when lone pair has attacked phosphorus, that chlorine, okay, that chlorine would have attacked. Okay, this Cl minus is there, which was there in the reaction mixture. This Cl minus was there in the reaction mixture because in this step when a lone pair attacked on oxygen, the Cl minus came out. So this Cl minus will go and attack on R from backside. Okay, this Cl minus will go and attack on R from backside because the nucleophile is attacking. Okay, because the nucleophile is attacking from the backside. From the backside, what do I call this reaction as? SN2 mechanism. What does this mechanism follow? SN2 mechanism because the nucleophile is attacking from the backside. Why is the nucleophile not attacking from the front side? Because this complete portion is very much chloride. That is the reason Cl minus is attacking from the backside, producing RCl. Okay, producing RCl. Now I told you oxygen is not stable with positive charge, so it will always be ready to pull this shared pair of electrons towards itself. So R, because it was electron deficient, oxygen was pulling the electrons, will go with Cl minus forming RCl. As it is following SN2 mechanism, it will show your inversion, and oxygen has got its the shared pair of electrons, so positive charge got neutralized. So it will be phosphorus, Cl, and this will be 1 OH. Clear? Now I got 1 mole of RCl. For the formation of 1 mole of RCl, I have used 1 mole of alcohol. Still I have 2 moles of alcohol which I can use here. Now let me take the second mole of alcohol. Okay, let me take one more alcohol. And now what is there here? PCl, OH. Now the same story repeats again. Phosphorus will want to take the lone pair of electrons from oxygen. The same story again because it feels a little electron deficient because chlorine keeps pulling electrons from it. Now what do we get here? Oxygen will get its positive charge, hydrogen here, and phosphorus. Okay, now when lone pair of electrons attack on phosphorus, the chlorine will be like, okay, you have taken lone pair of electrons from oxygen, now let me leave. Okay, now let me leave. So this Cl will leave as Cl minus. So what else is there on phosphorus? Now 1 Cl and 1 OH. The same story as in the previous case, you can repeat here. Oxygen will not take shared pair of electrons from here. Instead, oxygen will pull the shared pair of electrons from R. Now this R feels electron deficient. In the meanwhile, the Cl which has left as Cl minus here is there in the reaction mixture, and that will attack from behind, and this is my SN2 mechanism where I get my RCl with the inversion configuration. Where I get my RCl with the inversion configuration plus. Okay, now this oxygen has been neutralized because it has taken its shared pair of electrons. Oxygen has one more lone pair. I am not specifically showing that lone pair because it is understood for you people know because that lone pair is there. I am not showing it again and again because it makes it very clumsy. Okay, now what do I get here? Phosphorus, Cl, OH, and one more OH. Okay, 2 moles of alcohol have been utilized and 2 moles of RCl have been formed. Now let me take one more alcohol here. Okay, let me take one more alcohol because I have 3 moles of alcohol. Plus from here, what did I get now? See, I have taken only 1 mole of PCl3 and I am forming 3 moles of RCl. See how am I using that PCl3? PCl3. The same PCl3 I have been using, and I am in every step the derived form of it I am using. Okay. Here I have what? PCl, OH. Same thing again. Phosphorus will try to take the lone pair of electrons from oxygen, and R oxygen will get positive charge, hydrogen here. So PCl. Okay, now the Cl I can't write here because here what has happened? As soon as phosphorus has taken lone pair of electrons from oxygen, chlorine the same story again felt bad. It is like, okay, you have taken from it, now I am going out. Okay, this Cl minus will be there in the reaction mixture. Now I have 2 OH groups on phosphorus. Now, okay, this oxygen being positively charged will pull the lone pair of will pull the shared pair of electrons towards itself, and the Cl minus in there the reaction mixture will come and attack from the back side. This is my SN2 mechanism, and I'll get RCl, which has inverted configuration, plus I'm left with what? Okay, P OH OH OH. Okay, now this is not the stable form, because this is not the stable form. If you see, it is H3PO3. This is not the stable form of H3PO3, because if you know the P block elements part, okay, P block elements part, this is not the structure of H3PO3. How does H3PO3 exist? Okay, it has one phosphorus oxygen bond, OH OH OH. This is the stable form of H3PO3. This is the stable form of your H3PO3. So this is how the reaction has taken place. The reaction will take place in 3 steps. In the first step, 1 mole of alcohol has been used and it will form 1 mole of RCl. Okay, in the second step, okay, 1 mole of alcohol I will take, and I got one byproduct here of phosphorus that I will take, and again SN2 reaction will happen and I will get RCl. In the next step, 1 more mole of alcohol I will use. Okay, this byproduct which has come, okay, this the derivative of phosphorus trichloride, that will come here, and again, okay, SN2 reaction will happen. Inversion product I'll get. Along in the last step I'll get my H3PO3. Now I can't go further. Because if I go further, what will happen? If I go further, what will happen? It will not go further, because if I go further, okay, I will take my ROH, okay, plus it will be POH OH OH. Now phosphorus will not want to take this lone pair of electrons from oxygen, because previously chlorine was pulling it so much, but in this case, because it is OH, phosphorus will not feel a lot of deficit kind of case. So the reaction will not take place further. The reaction will stop as soon as your H3PO3 has been formed. So this is the mechanism involved in the formation of RCl from ROH. 3 moles of alcohol you can take and 1 mole of PCl3, forming 3 moles of RCl plus H3PO3. This is very important reaction. Sometimes they will ask you the balancing part, and anything can come from the reaction, and whatever RCl you are getting here, it is your inversion process, and the product is your inverted product. So it will have an inverted configuration when compared to your previous case. Clear? It will have an inversion configuration. I clearly explained you when I was telling you PCl5 only. Okay, the process or the concept of retention or inversion you can only see when you have a chiral compound. So if you are seeing in the exam, if you are seeing a chiral alcohol here, so kindly write the inverted product of it. Okay, we'll see an example to understand the stereochemistry, and we will also see, okay, PCl3 we have used it. Can we use PBr3, Pi3? If we can use, how we can use that, we will see now along with the stereochemistry by taking an example. Now let's understand the stereochemistry by taking an example. I have an alcohol. You can clearly see it has a chiral compound, so it's a chiral alcohol. When I react it with PCl5, you can see the inverted configuration. Which mechanism is involved here? SN2 mechanism is involved here. So you can see an inverted mechanism. So Cl will attack from this side, C2H5 goes to this side, and my benzene ring is here, and I have my CH3 here. So this is my chiral carbon. So chiral carbon. So what has taken place here? Inversion. So it will be your inverted product. So if this is your D configuration, it will be your L configuration. So if this has L configuration, this has your, okay, D configuration. I'm talking about small d, small l, dextro and LIGO. Plus what will be the byproduct here? So this I'll get 3 moles of haloalkane, and I'll have 3 moles of alcohol. Don't forget to balance. 3 moles of alcohol will give 3 moles of haloalkane plus phosphoric acid. So this is fine. We can use PCl3. The mechanism will be SN2. I can get the product. But what about PBr and Pi3? Okay, what about PBr and Pi3? When I was talking about PCl5 and Pi5, I clearly told PBr5 and Pi5 are very highly unstable, so we cannot talk about the reaction of alcohols with PBr5 and Pi5. Now when I talk about PBr3 and Pi3, let me take an alcohol, C2H5OH plus PBr3. Okay, and I'll also write the reaction of C2H5OH plus PI3. Now if we talk, will these reactions happen? Yes, they do definitely happen. But the only thing is here, okay, PBr3 and PI3, how to make them? Okay, how to make them? Because here I'll explain you a small concept here. Please try to understand. PBr3 and PI3, they are okay, and PI3, they easily break down. Okay, they easily break down. Means what? Okay, PBr3 easily break down into phosphorus plus Br2. PI3 also will easily break down into phosphorus and I2. That is the reason you will, in the laboratory, you will not have PBr3 and PI3 stored in the bottles, because they usually are get unstable and they break down into phosphorus plus Br2 and phosphorus plus I2. So what do they usually do? Okay, they prepare PBr3 and PI3, because they quickly break down. Okay, they are prepared in situ. Okay, they are prepared in situ. Means, okay, they are prepared in situ means what? What does it mean when I say PBr3 and PI3 are prepared in situ? Means prepared in the laboratory, prepared in the lab at the site of reaction. Prepared in the lab at the site of reaction. So if I'm doing my reaction here, I will immediately make prepare my PBr3 and I'll quickly use in the reaction. Okay, because so for example, I want to do my experiment somewhere half an hour from now. If I prepare PBr3 and keep here, and keep here, it is like it will decompose immediately, and by the time I take it to the side to the reaction, we are not stable about how it acts. That is the reason we prepare them in situ. At the site of reaction. Okay, we prepare them in situ at the site of reaction so that we can use them in the reaction. Okay, so what do they do? Okay, they will they'll make phosphorus react with Br2 forming PBr3, and in the same way phosphorus reacts with iodine forming PI3, and those are prepared in situ so that they can use at the site of the reaction. Clear? They can be used at the site of the reaction. Now what do they produce here? C2H5Br plus H3. Okay, now here it is H3PO3, so here also it will be H3PO3. The only change is here it will be Br. Now here it is 3 moles, here it is 3 moles here. The same way PI3 I can use. Here 3 moles of alcohol, here it will be 3 moles of C2H5I plus H3PO3. Okay, so these reactions will take place. Okay, PBr3 and PI3 will react and gives C2H5Br and C2H5I. So if you want to prepare haloalkanes, the halogen you want to be bromine, bromoalkanes and iodoalkanes, you can definitely make it. But instead of taking a PBr5 and PI5, which is not possible, you can take PBr3 and PI3 and do the reaction. But the only thing is, see that they are prepared in situ at the site of the reaction so that you can use them immediately. In the reaction, and they can give you your desired products. Clear? Because if you make and keep half an hour before so that you you think I'll use it at the time of the reaction, by the time you use it, they would have broken down into phosphorus and Br2 or phosphorus and I2. So make it immediately, make PBr3, PI3, use it, the reaction is done. Don't make it prepared before, only there you made at the site of the reaction. So this is how your PCl3, PBr3 and PI3 react with alcohol to form your respective haloalkanes. I have shown you with PCl5 today and PCl5 gaseous and solid form. Then I have showed you with PCl3 and the possibility of alcohols reacting with PBr3 and PI3. With PCl5 gas, it is SNI mechanism. With PCl5 solid, it is SN2 mechanism. Okay, clear with that. And when it is PCl3 also, it is your SN2 mechanism. So be clear with the stereochemistry of the reactions, because when you have to answer very good very good questions, you need to have a very good understanding of the stereochemistry of the reactions. I have put my heartful effort to make you understand the mechanisms behind these reactions. Now we are in alcohols, in the preparation of haloalkanes from alcohols. We are only left with the last reagent, which is my SOCl2 thionyl chloride. A very important reaction. It is your Darzan's reaction. That mechanism, reaction, what is the stereochemistry, all that we'll be seeing in the next class. Till then, keep watching our channel, keep loving our channel. I'll see you in the next session. Bye bye.